Hey, Vlad here, devinside.com. Welcome to another video. The time has finally come to start rewriting the to-do app. There's a lot of work to do, so without any further ado, let's get right to it. As in my previous videos, I'm using an Ubuntu 18.04 virtual machine and I'm using Windows as a host, which gives me virtual desktops with shortcuts that allow me to switch back to Windows like this and then back to Ubuntu like that. Same as in the previous videos, I'm also using virtual desktops inside of Ubuntu, and so I have the To-Do app open over here and the Expression Problem app open over here. I don't think that we will be touching the Expression Problem app today, but I kept it over there just in case. So let's go back to the To-Do app. Before we start the rewrite, I would like to point out that I actually made some changes after I finished recording the previous video. I'm always keeping the builds up to date and doing a couple of refactorings. Okay, so we left off over here, then added this funding.yaml, which basically just adds this button over here. So this is the commit that I have, and it's called between videos 4 and 5 and 6. It's a weird name. The thing is that the fourth video ended up having 2 parts, and therefore technically there are already 5 videos recorded, but there are only 4 parts. So today's video is going to be the 6th video, but technically it's the 5th part. So if we click over there, you're going to see that it's basically just an update to Scala FMT. I added an awesome plugin. I kind of wish that I knew about it before I recorded my previous videos. Basically, don't do any Tagless Final programming without this plugin. I'm going to point it out once we actually get there. So this is the plugin. Just updated a couple of versions, updated the SBT version, plugin versions. So max column was set to 100. I'm not actually sure why. I set it back to 80. So we have a lot of line formatting over here. You can basically scroll down. There's nothing major. This is probably the biggest thing. So this is the main loop that we're going to talk about in a couple of videos from now, probably like 2 videos from now. We're going to rewrite it. And I looked at it and I made it like a little bit shorter and a little bit more suitable for the rewrite that is going to come. All right. I think I wasted enough time showing you this. You can always go and click on it and look at it yourself, right? So basically, I did the same thing for the expression problem and also for the To-Do app. All right, let's go back to Ubuntu. All right, now as a reminder, I wrote this To-Do app a couple of years ago during one of my first Scala-related playlists. And during that time, my viewers were at the very beginning of their Scala journey. And so this app is far from perfect. There is virtually no error handling. There's no database. There's no web server. There's there are a couple of logical mistakes. There are a couple of unnecessary things. Essentially, it's just a big, slightly over-engineered toy app. Now, the way I structure all of my, let's call them full-blown apps, is by using what I have been introduced to as clean architecture, which essentially is just a version of any other layered architecture out there. Now, I have never made a dedicated video about it, but if you happen to have seen my Jitterate playlist, then you might be familiar with it. The gist of it is that we're always programming against interfaces, and we're using an SBT multi-build to make sure that the dependencies between those interfaces, that the arrows between them, that they point in the right direction, and so we end up without any cycles. We're going to run through the To-Do app real quick, but let's for now just concentrate on the layer. So we have the domain layer, which usually just contains data structures. It can have some logic, but it's the business agnostic logic, right? So it's not the logic of your application, it's the logic of your domain. In our case, what's inside, I'm not going to open it right now, but what's inside is just basically the definition of a to-do. It's just a case class to-do. There are 2 versions of it. One just contains the data, which is just a description and a deadline, which is just a timestamp, and the other version is just the ID and it contains the data, right? So it's basically data labeled with the ID. Then we have the core of our application that contains all of our business logic. Right now we have only one use case in there, which is like the CRUD use case. You can create, read, update, and delete. And the way the core is exposed to all the other layers is through a boundary. A boundary is just a simple trait which defines all of these CRUD methods, right? So at this point, the core has no idea how it will be delivered to our users, whether it's going to be a web app or a mobile app or what have you. And also it has no idea how the data will be persisted, whether we're going to use an actual database or an in-memory database or H2 or Postgres or Mongo or files or whatever, right? And then in the main, we basically just assemble all of it together. We're basically telling the core how to be delivered and how to persist its data, and that's all. So let me walk you through the app. Okay, so if I open the main file, as you can see, it's going to be open over here. So it's source main Scala com dev inside you to do, and there's a package called CRUD, and there's a file called main, which is not inside of this package. Okay, so all of the packages are going to be similar to this. So notice that this package does not contain any names of the use cases. So the use case is in this case called CRUD. So all of these, they will have a package called CRUD. The domain doesn't have it, which defines the to-do, right? So the domain doesn't have it, and the main doesn't have it, right? So the main at least has the name of the app. This is the entire domain, so we can have multiple apps for this domain. And all the others, like persistent delivery and core, they would all have CRUD as well, right? So the first thing that we're doing is we're assembling a dependency graph, in this case, just for this one use case. We have only one use case, so it's not a big deal. So we're calling, on CRUD, which is just a package, which is this one. We're calling dependency graph, which is just an object which lives over here. We're calling a method called DSL. It wants a pattern in this case. Okay, so if I jump in there, actually, let me go back and make sure that this tab stays. So if I jump in there, you're going to see that we have a dependency graph, which is just a function. It wants a couple of things. A couple of them are implicit, doesn't really matter. And then it constructs the controller. And the controller is a thing that comes from the delivery. So if I jump into the controller, actually, let me make sure that the tab stays. If I jump into the controller, right, notice where we jumped to, right? So we're now in delivery. Right, so the controller is basically just a trait that has a run method which returns a unit, and so in main eventually we're calling this method. All right, so if we keep looking at the dependency graph, so what the controller wants is this, this datetime pattern, and it also wants the boundary. So if we look into the controller, the trait doesn't know anything about it, but over here the DSL, it wants the boundary. So if we jump into the boundary, this is going to be in the core, right? So this boundary is just a trait which explains how this particular use case from core will be exposed to the rest of the application. And the rest of the application is just a delivery mechanism, which in this case is a controller, which creates a terminal user interface. Let's go back to the dependency graph. All right, so it creates this boundary, and the boundary, it happens to need an entity gateway. So if I jump over here, we're going to see not the trait, right? But over here, this method, it wants an entity gateway. If I jump into entity gateway, we're going to see that again, this is a trait. So this is essentially another boundary, but this is not the boundary to the core of the application. This is the boundary to the persistence layer. Okay. So the core defines the methods that it would like to call on the persistence layer. Therefore, this trait is at the same place where the boundary is, right? So they're both in core, and they're both for this very specific use case, which is CRUD. And then eventually, at some point, if we go back to the dependency graph, we're going to see that we're using an in-memory entity gateway. So if I jump in there, we're going to see that we ended up in persistence over here, and we have this object, and it returns an entity gateway, right? So it returns this trait. And essentially, this is the entire application. And by the way, notice another thing, okay? We have a couple of vars over here. They are relatively shared. I mean, technically they're inside of this tiny scope, so they're not shared. But as soon as we start talking about concurrency, which is going to be a couple of videos from now on, we're going to see that there's actually an issue over here, right? But we're going to keep it like this. It's going to stay for a while. We're going to keep things simple, because back then, when I originally recorded when I originally created this app, my viewers, they had no idea about concurrency. They had no idea about error handling. They had no idea about anything like this, right? So many edges over here are really sort of rough. For example, there is a method over here called write many. But what it does, it writes things one by one. If we had a real database, this would be very inefficient, right? It would be like a query for every insert, whereas we could insert many things using one query. We're going to do all of these things a couple of videos from now. All right, so basically I just finished walking you through the entire dependency graph for this particular use case. And since we have only one use case, we don't have any, if this was a web application, we don't have like any route or anything like this. So we manually creating the controller, which is basically this entire dependency graph, and then we're just calling run on that controller. And I'm thinking that maybe at this point we should actually run the application. So if I go into the terminal and I start SBT real quick. I showed you this already in the very first video, but maybe you've forgotten, just in case. So we're calling run, and inside of it, it's an interactive app, so it's going to present us with a menu, and then we click something, and then we can exit from the menu at some point as well. right? So let me actually create a little bit more space. Let me click over here as well. So again, like this is a multi-build. So if I type in projects, then we're going to see that there are all of these projects. And I have an alias to cd into projects. So instead of saying project main, I can just say cd main. And instead of run, I can just say r. So this is our application. If I just press enter, then it's going to keep showing me the menu. So press enter like this. And as you remember, I generated a random color for this line so that we see that the enter is actually being pressed. We can create a new to-do, for example, buy milk. And the date is going to be 2/20. I'm recording this on the 16th of June, so let's actually pick 16. So June 16 like this, and it's going to be, I'm going to pick the current time, which is going to be 9:18 like this. Okay, so now we have this to do. I can press SA for showing all to-dos. There we go. This is the to-do. I can delete all of them and I can show them again, and now they're gone, and that's it. All right, Q quits. Cool. All right, so let me actually close this one. So the plan for today is to just convert the boundary, right, which is all of that stuff, which is basically just this trait, converted to the Tagless Final style. During the expression problem part, which was the first part of the series, we have been using cats right away. For educational purposes, we're not going to use cats for now. What we're going to do is we're going to recreate all the parts from cats that we need, and I'm going to use the same packages and everything. And so a couple of videos from now, once we're done with the whole rewrite, we will be able to just replace, change a couple of lines in the build, and our application will still compile with the real version of libraries like cats and cats effect. Therefore, it's going to take a little bit more time, but it's going to, it has some benefit, right? So it's for educational reasons. So we're going to recreate a little bit of cats, and therefore it's going to take some time. Today we're going to do the boundary. In the next video we're going to do the entity gateway, and in the video after that we're going to do the controller. All right, so the way we're going to do this is we're going to use metals to rename this boundary to boundary old. All right, and I'm going to press Ctrl+Shift+P, save all, like this. All right, maybe I should keep using SBT, because the thing about Bloop and Metals is that once I save the file, it will try to recompile only the things that it needs. So in this case, it will only recompile the core. So if there's an error somewhere in delivery, it's not going to tell me until I actually go there, go into this file, and then Metals will ask Bloop, hey, what's up? Did it actually compile or not? So I'm actually going to go over here, and I'm going to say just compile like this. All right, so the main is at the very bottom of the dependency graph, so we're going to keep compiling like this. In fact, we're not going to run anything for today, so maybe we should actually keep using Bloop. It's going to be a little bit faster. So I have an alias for Bloop called B. So if I do alias B, we're going to see that it's Bloop. So if I do B compile to do and watch. All right, so this is all I need. Most of the time it's going to compile, so I'm going to create like only a little bit of space over here. Okay, so we have boundary old, so I'm just going to copy paste it and rename this one simply to boundary like this. Okay, so I'm going to close all the other files. Now it shouldn't compile because we have a duplication, so I'm going to rename all of that just to boundary like this, and it should be back to normal. Yeah, there we go. Now if I start changing this trait right away, adding our glorious infamous f, then the interpreter is not going to compile. So what I'm going to do is I'm going to take it, I'm going to comment it out like this. All right, so now we are ready to change this trait because nothing is using this trait. All right, let me actually collapse the sidebar, we don't need it. Okay, so all I need to do is I need to add this f. Okay, and now everything over here is going to return an f of whatever it was returning before. I believe if I can do this and just create a bunch of multiple cursors like this, just wrap everything over here and go like this and add an f, then the only one that I skipped was this one. All right, so now every method over here returns an f of something. If I do that, it's going to be too long probably, which is why Scala FMT does this thing. All right, now if I try to uncomment this thing, it's not going to compile. So we're going to try to visually identify what the entity gateway needs. What the boundary needs, and it looks like it needs the entity gateway. So we need to go there and actually do exactly the same trick basically. So I'm going to go there. I'm going to rename it to old, save all the files, hope that all is good. It seems like, yep, all is good. So I'm going to copy paste it. I'm going to rename it to entity gateway like this. Let's see, so we need the boundary, we need the entity gateway, and we can close everything to the right. like this. Okay, so this is the new one, so I can just rename it to entity gateway and do basically exactly the same trick. This is going to be F, and everything over here is going to return an F of that thing. Delete all as well. It's going to return an F like this. Let's see if everything compiles. It looks like it does. All right, so we can close this and we can basically go back to boundary, right? Because we don't need to work on the interpreter for the entity gateway yet. We're going to do this in the next video. This is the benefit of programming against the interfaces, right? So we already have the interface, so we can start working with it. So what I'm actually going to do is I'm going to collapse this, and I'm actually going to I want to throw most of it. Yeah, I'm going to throw it out. All right. So we're just going to do object boundary over here, and I'm going to open the old one. I'm going to open the old one as well. Boundary old, like this. Okay, so this is the old one, right? So we'll always have it on the right, and we will essentially just start like copy pasting things from right to left and changing them as we go. So the first thing that we're going to do is we're going to do that part. All right, so this is just going to be the DSL, just going to paste it like this, right? So it should compile as is. Probably, okay, we're not implementing a bunch of methods. I wanted it to compile and then change it, but we have to change it anyway. So I'm just going to remove old everywhere. And now we need to insert the F over here. And then we're going to have this F everywhere, over here, and over here. All right, and now it still doesn't compile, but now I can go and ask Metals to implement everything for me, implement all members. There we go, and now it should compile. All right, so let's try to bring the first one over, which is create one. So if I just copy that, remove that, bring it over, it's not going to compile, and the error message is going to tell me value hat is not a member of type parameter f of vector, right? So we're not dealing with a vector anymore, we're dealing with an f of vector. And the thing is that we're calling hat, and hat could actually throw an exception. Like usually in functional programming, you would not call hat, but as a reminder, I wrote this up 2 years ago, and in this particular case, it's going to be fine, right? So we're creating many, but we're passing only one thing, and therefore whatever it's going to return is going to be only this one thing. There's no error handling. We can always assume that it will always succeed to write this into the database, which is an in-memory database anyway. So the way we basically change an f of vector into an f of to-do existing is by using map. So all good things start with a functor. So let's go and create a functor. So for now, we're going to create it right over here. So we just go over here, and we're going to say that if we had a functor for some f, okay, that it would have a map AB, it would take some f of a. I have no idea how many times I have recreated functors during my videos. I've been making these videos for like 3 years. I have like 180 videos right now, and it's probably like the 10th time that I'm typing out this functor. Okay, so as a reminder, a functor lifts a function that goes from a to b into the function that goes from f of a to f of b, like this. All right, so assuming that we have this functor, then we will be able to request it. So we will be able to say, if we had a functor over here, so I'm going to use this syntax for now. I'm going to say implicit. I'm going to call it functor for f. Then I would be able to go over here, and I would be able to say functor dot map, pass in this entire thing. This is what I'm mapping. And the second parameter is going to be, come on, like this. The second parameter, like this, is going to be the function that would take the vector and map it to an existing to-do. Now, as we already know, we don't like this notation, this typical like functional notation. We want to convert to be able to use the the object-oriented notation, and so it's a common thing, at least in Scala 2. If you have seen my previous video in Scala 3, this won't be necessary anymore. But at least in Scala 2, we would need to do something like this: final implicit class, functor ops for some f and some a. So we're going to take a private val f of a, right? And we're going to assume that there's a functor for it, functor for f. Then this thing, this f of a, is going to have an inline function called map. It's going to take a function from a to b. It's going to produce an f of b. and it's just going to do that thing for us. It's going to call f of a with a to b, right? So if you haven't seen some of my previous videos where we're doing this all the time, we're basically uncurring the parameters, so to say, or no, we're actually curring them, okay? The type parameters, okay? We're saying that the f of a is going to come over here, but the rest is going to come over here. So we're just basically splitting them apart. And now that we have that, we can go over here, and instead of this, we can just do create many the same as you would do with lists or whatever, and just call map over here. Right, so this is the object-oriented notation. Let's remove this line so that it actually works. There we go. Now the next thing that we're going to do is we're going to improve a lot of the syntax. In fact, let me actually create more space. So this is a lot of boilerplate, right? So what we're going to do is we're going to switch to using context bounds. So there is a notation for, let's actually do this over here first, okay? So there is a way to say that this f, it should just have an instance for a functor. Okay, therefore we're not going to need this, but in this particular case we're actually using the name, so we need to actually go back and retrieve it. So we would say implicitly, please give us the functor for f, and then this thing is going to compile, right? We could do the same thing over there, what we're not going to do, because what I'm going to show you now is even better than this. Before that, let me actually show you the summoners. So what's being done in libraries like cats is something like this. There's an object functor with an apply method, and it basically looks exactly like the implicitly function, right? This one. And therefore, if we have it, it will produce a functor for f, right? So basically it will do this part for us like this. And now that we have it, we can just call apply, and we can do this, right? So this is much shorter, and this is what you will probably see in most Tagless Final code bases. Now, the next thing that I'm going to show you is that comes from this awesome plugin that I mentioned in the beginning of the video. So if I go to dependencies, which is just a catalog of all the dependencies that we could potentially use, one of them is this one. It's called context applied, and if I go to the build, we're going to see that somewhere in the common settings, we're using it over here. It's a compiler plugin, right? We're also using the kind projector. Right. So what this plugin does, basically, it notices that when you have methods that use context bounds, like for example this one, right? So there's a context bound in this entire scope, and it's called f. So behind the scenes, what it will do is it will go into this scope, and it will do something like it would create a trait blah. It's basically going to be like a bag of methods. Okay, and then it will, this is pseudocode, right? So it will take all the functions that are coming from all of these context bounds. So in this particular case, it's only functor. So it's going to do something like, def map, and it's going to, recreate the entire map. And then behind the scenes, it will grab the functor for you, implicitly functor for f, right? And then it will call map for you, right? So it will do this like with all the DSLs that you're using. For example, if you're using flat map, right? It's going to be something like this. Flat map and flat map. And then what it goes is, and it does this, it says, so there's going to be a val f, right? Capital F is going to be a new bag of methods, right? And then on this f, you're going to be able to call map and flat map and all of these, right? The only tricky thing that you need to know about this, that if you for some reason have a collision of the method names, right? So for example, let's say, both functor and flat map, let's say they both define a map, like a different version of a map for some reason, then instead of like failing, what it does is it takes the first one, right? So the order of the context bound matters. But in practice, this usually never happens. Okay, so basically without any annotations, without anything weird, you just throw this compiler plugin in there, and anytime you're using a context bound, you will have access to this f, right? To this val f. So what we can do is I can throw all of this crap out, and instead of even using the summoner, I can just use f over here, right? I can just do this, and it compiles exactly the same as before. All right, so now we don't even need the summoner. Okay, so I can throw out the summoner. I can go over here and I can put the basically do the same trick. I can do the functor over here, and I can throw this out, right? So in this particular case, we're not even using the name, but if we wanted to, we could, right? So we could still do f.map, for example, right? So create many vector to do, and over here, what are we doing? Okay, over here we would do hat. right? So this still compiles, right? So now you have access to this app, and it has all the methods that you need from all of the context bounds. I so wish that I knew about this plugin before I recorded the previous videos. I actually removed the wrong one. All right, so we have the create menu. It turns out that for now, all we need is a functor. Now, as already mentioned in the beginning of the video, I want to recreate the parts of cats that we need. In this particular case, it's just a functor, just for now. And therefore, I want to put it in all of the appropriate places so that in the end of the series, once we go into change this one line in the build file, everything else should still work, right? So the import should stay exactly the same. Everything should stay exactly the same. So let's go and start working on that. So if I go to the build, what we're going to do is I'm going to go to the top where we aggregate a bunch of projects. I always forget to add, new projects to the aggregate, which is totally unnecessary, but still. So I'm going to go and I'm going to add cat's core somewhere over here. Cat's core, okay? And cat's core is going to be, let me clone that. Let me have it over here. So it's going to be called cat's core, okay? And it's going to be technically like 0, 0. This is, by the way, another thing that I sort of forgot to mention, right? So like these numbers, I just try to like replicate the dependency graph so you kind of see like, the way the errors are going, okay? And therefore, starting with 1, therefore like everything else, we're gonna throw it out eventually anyway. So we're just gonna call 0, 0 cat's core like this, all right? No, not now. And now we're going to skip the domain. We're going to go to core, and we're going to say that it doesn't only depend on the domain, but it also depends on cat's core. Okay, cat's core, like this. By the way, this is just a val. Okay, metals cannot jump in there. So there's a file somewhere called utils, okay, and somewhere at the bottom it has this thing. So CCTT stands for compile, test. And this is one of those weird SBT thingies that you need to know, is that by default, if you have source code dependencies between projects, by default, it's just the compilation scope depends on the other compilation scope or access or whatever they're called. I always mix them up. And by doing what we just did, we have exactly the same dependencies between the tests as well, right? So the tests in this particular case, the tests and core, they will depend on the tests in cat's core and in the tests in domain. We're not going to write this test anyway, I think, maybe at the very, very end of the series. So I believe that we have everything that we needed. So we have this project. So if I actually import the build now, and I'm not sure if Metals is going to do this for me, but SBT will do this for me. So if I actually go and go over here in the terminal, let's create another terminal. Let's go and okay, it actually did something for me. Yeah, okay, that's good enough. Okay, cool. So it created this this folder for me, which is exactly what I wanted. I don't need more. So what we're gonna do is we're gonna go to cat's core, and I'm just gonna open it like this. I'm just going to right click on it, and I'm gonna say new file, and inside of it we're going to create the entire structure. So it's gonna be source main Scala, cat's core, and over there it's gonna be the functor like this. All right, so now I can go to the boundary, and I can cut out the functor, put it over here, go to the boundary, make sure that we now import cats, just everything from cats like this. If we save the file, everything should still be fine. It's not fine. Why is it not fine? I imported the build, right? What does it say? Not found type functor. What is happening? Oh, it's called cat's core. So Metals did this thing for me where I just looked over here and created cat's core. So let's just remove that. It should be called cats. All right. So, and this is also the reason why very often I'm not using bloop in my videos, because as you have seen, I just saved the file, but it didn't notice this change. So I actually need to go over here and I need to ask it to compile again, and now it's going to say that it's fine. But for now, I'm going to keep using it anyway. All right, so let's move this guy as well. So we're going to go into cat's core. It's going to be a folder. I'm going to call it implicits, right? So we're not going to recreate cats like exactly like one-to-one. It's just a necessary part so that all the imports still work. So now I can go over here and use Scala file. This is going to be a package object, okay? Package object implicits. I'm going to go over here, cut out this thing, go in here, paste it in. And it's not going to be cat's core, it's going to be cats. And come on. All right, not found value app. This happens because I forgot to do something in the build. So if we look into the build, then like most of the projects, like except for the domain, they have this thing settings, common settings, right? And in the common settings is that part where we're using this plugin, right? So if I go over here, this is where we're using this plugin. And I forgot to do this part for cats. So let's go do this real quick. Where is it? It's over here, like this. And let's also do this for domain. I mean, why not? We're not going to touch the domain actually, like in this entire series. We're not going to touch the domain. Maybe I should actually show it to you while Bloop is doing this thing. So inside of the domain, we have only one file to do over here, right? And it's basically a seal trait and case object to do. Okay, so over here, I use like a weird version of the f-bounded polymorphism back then, because I wanted basically that to have like these helper methods, right? Because we're not using lenses or anything like this back then. So specifically for these methods, like these update methods, I wanted them to return this concrete type. So over here, when we have like these two versions, the existing to do and basically just the data, they would override this type, right? So inside of this, the type is going to be existing. Inside of this, the type is going to be data, and therefore, when these methods are being overridden, the concrete type is being returned. Right, I believe this is actually built into Scala 3, and I believe they call it transparent types, right? It's kind of weird that they're introducing like transparent and opaque types. Not confusing at all. In any case, I believe it actually finished. Let's go to terminal. Let's kill it. Let's ask it to compile everything again. Value map is not a map. Okay, so this is correct now. So this basically just tells us that we need to have the import cats implicits like this. All right, so this is pretty much like all of the machinery that we needed. So everything that we're going to do from now on is going to be much smoother because we already created like all of these places where we can, put things nicely. All right, I don't like these unnecessary new lines. All right, so I believe we can continue. So let's look at create many. Let's go over here. Okay, so create many just calls write many. So let's go and try this. Create many. Write many. Not found value write many. All right, what's up with write many? I think it's a private method. It's a private method, yes. So let's go and copy that. Write many probably needs to return an f of this vector. By the way, notice that I'm not even like reading like what's inside of this code. I'm just looking at the types. Like all we're gonna do like in the next couple of videos is basically looking at the types, playing around with the types, massaging them until everything compiles. It's going to be a very, very mechanical transformation, as you have just seen. Like I don't need to know what it's doing. If it compiles, it's probably fine. And if it's not, then we're going to fix it in a couple of videos. Right, let's keep looking. Okay, read one by ID is calling read many. Okay, so it looks like we're going to do the same trick as we did with the head. So it's doing like this head option. It's going to tell us exactly the same thing. So we're going to go over here, paste this thing. It's going to tell us, yo, you need to call map like this, right? It's all good now. By the way, if you're curious, we're doing some trimming over here. I remember back then struggling with this fact that a to-do app doesn't have like too much business logic. It's just a CRUD app. So I try to simulate that that the core layer was actually doing something useful, and therefore we're doing some trimming over here. All right, let's continue. So we have read many by ID. Okay, so I'm pretty sure that this is just going to compile like this. Right, so it just calls the gateway, right? And the gateway already returns an F, so it's already prepared. Let's see, read many by description. Oh, over here, see, it creates a vector, but now we're going to be forced to create an F of vector. So this is going to be the part where we're going to need an applicative. So let's go over here. Go over here. Do that. So this part is going to be fine, right? But this part is not. It's going to tell us, I found a vector, but I wanted an F of a vector, all right? And this is where we need the applicative. And I always recommend you guys to do this. And then the compiler will tell you what you need. Assuming, you're using actually, the real cats library, then it will tell you, hey, in order to call this, I would need an applicative, All right, so let's go and create the applicative. We already have space for it. So if I go to Functor and then just press Control N and I press save and I call it applicative.scala. It's not going to be cat score, it's just going to be cats, and we're going to have trait applicative for some f. It's going to extend the functor. Applicative is a short name for an applicative functor. Okay, so it's just going to have a function called pure, which can raise an a into an f of a, like this. All right, and now let's go into the package object over here, and we're going to create another syntax class. I'm going to say final implicit class. It's going to be called AnyOps because notice again, I mentioned this probably in every video, but over here we're calling pure not on an f, we're calling it on whatever we want to wrap. So this is going to be AnyOps. Okay, so our val over here is just going to be some a, which is going to come over here. Okay, so it's going to be a. This is the only one that can actually extend any val. Okay, so we're going to do add inline def pure f, assuming that it has an applicative. Going to return f of a. And by the way, this is also probably the only one that will have this context bound on a method and not on the class. Right? So we can use the plugin again to just return, to retrieve this f, and it's going to have all the methods that are defined on the applicatives. So we're going to have access to map and we're going to have access to pure. So we can just say pure a like this. All right, so as you can see right now, it doesn't compile. And remember that I told you that this plugin, what it does, it generates a val f. The issue is that you cannot have any vals in an any val class, and so it is smart enough to not generate it. So all we need to do is just remove this extends any val like this, and it compiles. So now the only thing that doesn't compile is the boundary, and now it doesn't compile with the appropriate message, right? So now it says I could not find an implicit value for evidence parameter of type cats applicative. And so oh, okay, so I need to go and I need to say that I don't only need a functor, I also want an applicative, right? So you just slap it on there and everything still compiles. And then if you're curious, you're going to jump into applicative and you're going to see, oh, an applicative is already a functor, so I don't need to request both. I can just do this, and that's it. All right, as you can see, it still compiles. All right, let's continue. Let's go. So we have read all. I believe from now on everything is going to be boring. So read all is just doing that. That should still compile. Yep, and this looks again like another functor thingy. So update many over here. So we're just gonna do map that had like this. What else? Update many. Yeah. So from now on, everything is kind of boring, and we're pretty much done anyway. So write many, delete one is going to be like this. Yep. Yes. Everything else still compiles because everything else pretty much just delegates stuff. All right, and we're going to have delete all over here. By the way, notice that we can pretty much close this, right? We have the entire thing already. The ones that they don't have any parameters, because we're dealing only with descriptions now, right? We actually there's no need to calculate this description multiple times, so we can safely use a val over here. Let me actually see if I skipped some others. Yeah, so this one, and yeah, that's it. So here we go. We converted the entire boundary. It looks like all that it needed was an applicative and obviously the entity gateway. We're using implicits, for like mechanical things like applicatives. It's actually kind of hard to decide sometimes, like should I inject the applicative like implicitly or not. I mean, for things like applicative, it's pretty much clear, but like for your own DSLs, it's going to be tricky. You're going to see it in the upcoming videos. The decision is not going to be so easy anymore. All right, so basically we just have an f everywhere. Now we're using an applicative, so instead of calling .had right away, we're using map, and in one place we're using pure. But apart from that, like everything else pretty much stayed exactly the same. It was just a very clean natural transformation. I shouldn't use the words like natural transformations. They have a very specific meaning in the functional programming world, but it was a very mechanical transformation. All right, I believe that this is actually enough for the first video. We didn't write much code, but there was a lot of commentary that was necessary to to get us started. So let me review everything we did, and I'm going to clean this up just in case I missed something, and then we're going to commit this, and yeah, that's going to be the end of this first video. Let's see, if I do Control Shift G and then press G again, we're going to see all the changes as a tree. So yeah, that looks fine, that looks fine, that looks fine. Boundary, okay, bunch of renames, all of that stuff. Controller, oh yeah, so it's just the renames, and in the build, okay, so we added cat score over here. We added the common settings to the domain, which probably doesn't need it, but still. The core depends on cat score now, and yeah, that's pretty much it. So let's open another terminal over here, and I'm just gonna do, remember I have an alias gcam which adds everything and just commits everything, so I can just do gcam. Whoa, that's not what I did, that's not what I wanted to do. I pressed enter accidentally. Let's see, hold up, what did it do? Did it create something? No, it didn't. Okay, so I can just do it again. So it's going to be video 6, which is technically part 5. So yeah, let me do this part 5 just in case, more information is not going to hurt. All right, let's push that. GP just pushes that. Let me actually show you this. Alias GP just get push. All right, so let's go over here, let's go back and refresh this page, and there we go, and we should see all of our changes. Right, just added applicative, just added the functor, just added the syntax. Okay, it shows us that we changed the boundary, but we actually didn't. We renamed it to boundary old. We added a bunch of f's, added the context bound for the applicative, and there we go. That's just the old one, was the renames. That's the old entity gateway, and yeah, that's pretty much it. All right, so I hope that you enjoyed this video. We're gonna increase the pace a little bit in the upcoming videos, because there is like things like the entity gateway and the controller, like the things that are like in the outer layers, they have way more code, and there's some of the things that are also going to get like a little bit more complicated. I believe in the next video we're actually going to learn about traversable functors for the first time on this channel. So anyways, I hope you enjoyed this video, and I hope you're excited to see the upcoming ones. For now, it's been Vlad, devinsideyou.com. Don't forget to like this video if you did, subscribe if you want to improve the developer inside you, and if you learned something today, consider support me on Patreon and thus watch my videos weeks and sometimes even months before everyone else. And most importantly, take care.